All right, good morning class. We're going to go over section 2.4, reasoning. So in Algebra 1, we went, in Algebra 1, I told you what to do and then you did it, except everything we said. Now you're going to prove each step of the way, everything that you did. So next thing I want you to do is take notes of each one of these properties. So you're going to have addition, subtraction, multiplication, and division. These are all properties you'll need to remember. What you'll do is you'll solve an equation and you'll state what property you're using. So those are old ones, things you've been using for a while. New ones, you're going to have reflexive, symmetric, and transitive. So reflexive property is, it's a mirror. One equals the other. A equals A, B equals B, D equals angle D. So the same thing equals the same thing. Symmetric property is 2. A equals B, then B equals A. We can switch the order. Transitive property now states if A equals B and B equals C, then A equals C. We have 3 now to it. Substitution property, remember if A equals 5, then we can plug 5 into the equation. And then distributive property, whatever is on the outside, we multiply to the inside. So we're going to go through a couple of these. Again, just want to show you reflexive property, symmetric property, and transitive property because they're new. This is how you'll see it. Line AB equals AB, line A equals line A. Symmetric property, AB equals CD, those type of things. And then the transitive property. AB equals CD and CD equals EF. Then we know that AB can equal EF. So I want you to write down those properties. Now, next, we have 3 or 4 examples to go through. So first example, we have 2 times x plus 2 times 3x plus 1 and 5x plus 14. I'm going to zoom in a little bit so you can see it. So we want to solve for this equation right there. So the first thing we're going to do, if we looked at it, is you're going to have to, here's our next step. So what do we go? This is how I do. How do I go from one step to this step? Well, we distribute 2 times 3, 2 times 1. So that's the distributive property. I know first step should always be given. What did they give you? They have to give you something to solve an equation. Now we go from here. What happened? How did I go from 6x to just x? Well, I subtracted 5x, so I'd say that. Subtraction. Now you look at your last step. You have x equals 12. What happened to this 2? We subtracted it, so we'd say that again. That's what we talk about when justifying our steps. We have it solved out and our reasons for each one. Another example, yes, I want you to write it down. Similar to the previous one, we have my first step is here. We always write given. That's what's given to us. Now we want to go ahead and solve. So we distribute. Now you look at your next step, so we'd say distribute it. Now we look at the next step. What happened? How do we go from 55z to 28z? Well, we combine like terms, so you can say combine like terms or you simplify. If they're on the same side, we just simplify. If you said subtraction, I would accept it as well. Now, what happened to the next step? How did I go from this 36? What happened to 36? It went away. How did it go away? By adding it. So we'd say addition. And then our last step, we go ahead. How do we get rid of 28? We divide it, so we'd state that. Division property. So that's 2 examples I want you to write down. So now we'll go to our next example, and we'll back it up a little bit. So here's our example. I'll zoom in so you can see. So I want you to write down that example there. And then I'm going to back out, and we're going to go through our example here. So we want to go step-by-step process of what we have. So we're going to go through postulate that we learned in chapter 1. So you accumulate all these postulates, they don't go away. So if I have this whole line segment, N to O, then I know this part and this part. what we can say is that our part, or the whole thing, NO, the whole thing is equal to the smaller parts added together. What do we call that? Segment addition postulate, or you could say segment addition segment, either way. So now we go ahead and we look at it. Well, what does NO actually equal? Well, it equals 4x minus 4. And M equals 2x. So what we're doing is we're substituting the actual values in. And now we can go ahead and solve this algebraically. So again, I look at it. What happened here? What did we do? Well, we combine like terms. 2x plus 3x is 5x. So you could say addition, you could say combine like terms, or you could say simplify. Now we're going to move this 4x, we're going to subtract it. So we'd say that, subtraction. And how do we get rid of this 9? We add it. So we say addition. So those are the steps we would do. Last example. Now we have an angle, right? And what we have is angle ABC. ABC, right here is 8x. This part right here is 3x plus 5. This is 6x minus 16. Again, an old postulate. So we're going to set up similar to the last one. This whole angle, ABC, is equal to ABD plus DBC. That would be angle addition postulate. Now, what is actually angle ABC equal to? It's equal to 8x, so we're going to substitute in the actual values. Once we do that, we're going to combine like terms. 3x and 6x, 5 and negative 16. So when we do that, that's simplifying, or you could say addition. We added them together. Now we can go ahead and solve from there. So we subtracted 9x to get negative x. How do we get rid of the negative sign? We divide. So that's our process of what we're going to do. We need to justify each step. Make sure you got all those examples written down.